We got 1518 water bottles. This is an easy problem, and just to restate it, it says the following: there are none bottles, water bottles that are initially full of water. You can exchange empty water bottles from the market with one full water bottle. The operation of drinking a full water bottle turns it into an empty bottle. Given the two integers, num bottles and num exchange, return the maximum number of water bottles you can drink. Example 1, we got an input of num bottles 9, num exchange of 3, output 13. Explanation, you can exchange 3 empty water bottles to get one full water bottle. Number of water bottles you can drink, 9 plus 3 plus 1 equals 13. Input, example 2, we got an input of number bottles of 15, num exchange of 4. Output of 19. Explanation, you can exchange of 4 empty bottles to get one full water bottle. Number of water bottles you can drink is 15 plus 3 plus 1, which equals 19.
Yeah. So to go into a little bit more on our initial approaches, um, you could see like based on the visuals, you could sort of like divide, right? Um, you could divide the things. So when understanding the problem, I basically looked at the visually like, okay, you're gonna have initial of 9 bottles that are filled, and you're gonna drink them all. So now you have 9 empty bottles, right? With the num exchange being 3, you could exchange 3 bottles, empty bottles, for one full bottle. So since you have 9 empty bottles, you can exchange it 3 times because the rate is 3. So now you got 3 full bottles now. Again, you drink the 3 bottles. Now you have 3 empty bottles. And lastly, you can exchange that again for one more full water bottle, and then you get an empty bottle. So that's how you come up with the 9 plus 3 plus 1, right? Um, and yeah, that's basically it with that.
Yeah. Yeah, like Carlos was saying, our initial approach was just to use modulo and a division just to see how many from the empty bottles you use the division to get how many um good water bottles we have, and then the modulo to see if we got any remainder. If we have any remainder, for example, in example 2, we carry those 3 right to the next exchange, right? But since we already got 3 filled water bottles, those are eventually going to become empty water bottles, so we have to take those into consideration even though they're still filled. So when we take those into consideration, we're eventually gonna get the total of 6 empty water bottles. So that loop just continues and continues and continues and continues, and it ends until there's not enough water bottles to do the exchange. For example, on example 1 and 2, at the end, on example 2, we got ended up with 3 empty water bottles, which is less than the number exchange, which is 4. That means that we can get no more water bottles. Thereof, we have finished with this um with this iteration.
Yeah, so the actual approach we then took was to utilize that loop, like Jose was saying. We wanted a while loop, and that perfectly gives us the opportunity to keep going until those empty bottle conditions are met. Like if there's 3 empty bottles, obviously you can't exchange anything anymore because the exchange rate is 4. So that's what this we decided to use a while loop in order to start that process. And of course, we had initial values that basically set up the problem, as the problem stated, that you have initial of 9 bottles, then you're gonna have initial of 9 empty bottles since you drank all those. So that explains 8 and 9, lines 8 and 9. And then that's when we started to use the modulo and division operations. We said if we want to get the remainder of empty bottles after doing the exchange, we need to do the modulo operation. If we want to get the number of new filled water bottles, we need to do the division operation. And it's not truly the division operation, it's the floor division operation since we're using these 2 slashes right here. So that means whatever, like if you had 1 slash, then they'll give us a decimal value. But since we do 2 slashes, they'll give us the floor of that. And then after that, we want to update the number of empty bottles because if you look at example 2 right here, the number of empty bottles is 9, but then once you go to the next stage, yeah, the number of empty bottles is going to be 6, right? So you got to update from 9 to 6. And then you update the total drink, and then you just return the total drink at the end. So I think key takeaways for me here were simply like, at first I didn't really understand the problem, but visually looking at these graphs helped me understand, like, okay, you get the initial amount of filled water bottles, you drink it, and then you got to exchange it. Before, I didn't really know what exchange was doing, right? So obviously this problem helps you out because they give you the image, but if I didn't have the image, I would have drawn out this problem and eventually understood it. But I think my key takeaway is going to be that.
Uh, yeah, I would say the same thing related to the visuals, right? The visuals, if there's any visuals in the problem or something like that, they really give you the resources that you will need to solve this problem. For example, here we got the filled bottles and the empty bottles, and then here in the same visual shows you how they relate to each other and how they work within each other to solve this problem. So for sure, understanding the visuals and seeing how you can extract the information from the visuals and see how that information interacts with that within each other, and see the translation of the information into variables, coding, algorithms, or so on and so forth is going to help you a long way to solving problems like this.
Nice.